called Roots of Real Numbers. The whole title for all of Chapter 6 is called Irrational and Complex Numbers. We're going to get into something called, bless you, imaginary numbers. Bless you. So a complex number is a real number and an imaginary put together. So it's like looks like a binomial, but it's going to have a real number part and an imaginary part. So today we're just starting with real numbers, which makes it a little bit easy. And we're going to start by talking about perfect squares and square roots, okay? So 1 squared is basically 1 times 1, which is 1. It's like pre-algebra right here. All right. So if we go the other direction and we take the square root of 1, because that's the square root of 1 squared, we get 1. So 2 squared means 2 times 2, which is 4. If you take the square root of 4, that's the square root of 2 times 2, which is 2 squared. So it's 2. Okay. Let's do one more. Let's jump down to 14 squared. 14 squared is 14 times 14, which is 196. So if you see the square root of 196, that means the square root of 14 squared. So the square root is 14. These are what we call perfect squares. What makes them perfect? Right? They don't have whole numbers, or they don't have decimals. They are whole numbers. So what happens if you get a number that's not a perfect square? Like example number 1. We're going to have the square root of 32. There are 2 perfect squares that are near it, right? 1 just before it and 1 after it. What's the perfect square that comes right before 32? Right, the square root of 25. And what's the one that comes right after it? Square root of 36. So if we were to punch the square root of 32 in a calculator, what would it say? 5 point something-ish, right? Maybe 5.5-ish because it's almost kind of in the middle, okay? But I don't want a decimal answer. I want what's called a simplified radical. Which means no decimals. And that means we need to take the prime factorization. You guys have all done this before, right? With a factor tree where you draw the little lines going out. Okay, so if we start with 32, because it's even, we know that 2 goes in there 16 times, right? And 2 is prime. So we can't factor that anymore, but 16 is not prime. It's what we call composite. And so we can factor it more. Because it's even, we know that 2 goes in there 8 times, 2 goes into 8 4 times, and 2 goes into 4 2 times. Now, every pair of factors, one of them will come out from under the radical, okay? Not both, just one of them. And any of the prime numbers that do not have a partner or a pair are going to stay under the radical, okay? So when we go to simplify this, we have one of the 2's from this first pair, and we have one of the 2's from this first pair. Those both come out from under the radical, and this one stays under the radical. And then we simplify this to 4 rad 2. Another way to do these without doing this prime factorization is if you can recognize perfect square factors. You can look at 32 and go, oh, I recognize that 16 is a perfect square factor of 32, you can say that this is equal to the square root of 16 times the square root of 2. Now you can do it a little bit faster. Square root of 16 is 4. This doesn't have any more perfect squares, and so you're done. Okay? So whichever way is faster for you, or whatever one's recognizable. So most of you are pretty good with perfect squares up to like what, 12, up to 144. Okay. The rest of them you can do on your calculator, right? Okay. Example number 2. If you have a negative sign out in front of the radical, think of it as a -1. So this is the same as saying -1 times the square root of 9, and the square root of 9 is obviously 3, so it's -1 times 3, which is -3. Okay? This is what we call a real solution, versus if you have the negative under the radical with the 9. Okay? So you see the difference where the negative sign's out? This one's out front, this one's under. So if you have a negative sign under the radical up until this point in Algebra 2, you've always been told that the answer is what? No real solution. Okay? The reason is there's an imaginary solution to this problem. Anybody know what it is? What is it? 3i. Yes, it's 3i. It's 3i. And we're going to get there in the next, I believe it's section 2, but in the next couple lessons. Okay? What if you have a fraction under the radical, like example number 3? What if you have 1/9 underneath the radical? You need to square root both of them. So you're going to separate it to the square root of 1 over the square root of 9. And the square root of 1 is just 1, and the square root of 9 is just 3. Okay? Now let's get a little more complicated. I'm going to move this up. You'll see it in just a second. All right, number 4. What if you have a fraction under the radical that is not perfect squares? Okay, so example number 3, 1 was a perfect square and 9 was a perfect square, right? So we got 1/3. Nice. Okay, is 12 a perfect square? No. Is 32 a perfect square? No. Okay, so I'm going to show you how to deal with that. But first, see if you can reduce this. Okay, always look to see if it can be simplified or reduced before you do that. Can this be reduced? Yes, that's why I'm asking, right? So they're both divisible by 4. So this simplifies to the square root of 3 over the square root of 8. So is there, it's okay to have a radical in the numerator, but it's not okay to have a radical in the denominator. Okay, so the numerator is okay, denominator is not okay. Right? Does anybody know how to get rid of that denominator, that's the radical that's in the denominator?
You multiply it by.
Right. So we're going to take this and we're going to multiply it by that denominator, which is the square root of 8. And you can always multiply a fraction by 1, right? You can just write 1 in a bunch of different forms. So one of the forms that you can write 1 as radical 8 over radical 8, which simplifies to 1, just like 8 over 8 would simplify to 1. Does that make sense? Okay, so we're multiplying by 1, and then we're going to just multiply straight across. So the square root of 3 times the square root of 8 is the square root of 24. And in the denominator, we have the square root of 8 times the square root of 8, which is the square root of 64, which most of you in your head have already figured out that the denominator should be 8. Then for the numerator, you just want to see if you can simplify it. Are there any perfect square factors of 24? Yes. Yes. It's the square root of 4 times the square root of 6. So if you can recognize it, great. If you can't recognize it, then do a prime factorization tree and see if you can figure it out, okay? So the square root of 4 is 2. So this is 2 rad 6 over 8. Can I simplify it anymore before I give my final answer? The 2 eighths reduces to 1/4. So this is the square root of 6 over 4. Can I reduce it anymore? No. Don't be tricked and think that, okay, there's a 6, I can reduce that with a 4. You can't, because this one's under a radical and this one is not, okay? So we could reduce the coefficient, but we can't reduce with the number that's under the radical, okay? Unless they were both the same. Like if you had the square root of 6 over the square root of 6, yeah, you can reduce, okay? All right, any questions on example number 4?